Hey, so this is a lesson on rearranging equations. So this is Mr. Latte's patented formula rearranging technique. If you want to use this, you have to pay me a royalty every time you use it. But this is how you rearrange 95% of the formulas, and it's the easiest thing ever. So when a formula has all multiplying and dividing in it, it's the easiest thing in the world to rearrange. There's just a couple rules. So the variables can move diagonal across the equal sign, but not up or down or side to side. And you must also make sure that the isolated variable ends up on top. Those are the only two rules. So if you had an equation that looked like this, a over b equals c over d, this is how you would rearrange it. So I'm going to switch to this. So we have a over b equals c over d. We're trying to isolate a. So the problem with this equation, the way that it is b. b is, if we want to isolate, we want to make sure that a is the only thing on this side of the equal sign. So b can't move side to side, so b can't move beside d. It can't move up and down, it can't move beside a. So b can only move diagonally like that. The equation is rearranged. So the other one that we have, a over b equals c over d. If we want to isolate d, well, we have to follow that other rule. Because d is on the bottom, the first thing you have to do is make sure d is on top. Okay. Now that we have d on top, we have to get rid of a and b. So b can move diagonally beside c, and a can move diagonally down there, and it's rearranged. That's it. That's how you rearrange equations with all multiplying and dividing in it. Really easy. Okay, so let's take a look at a real formula. So this is spring potential energy. So this big E represents E, and then these little letters represent what type of energy it is. So it's spring potential energy, so I call it EPS. And then that equals 1/2 mv squared. So we want to isolate K. So EPS equals 1/2 kx squared. So we can write it two ways. We can write it as that 1/2 is on top, like that, and 1/2 is a little variable. Or we can write it as EPS equals kx squared, and then write 1/2 like that. Both are correct. If we have a 1 there, it doesn't make a difference. So we can call it kx squared over 2. And whenever something is by itself, it means it's on top. So to rearrange this first way, if we want to isolate for k, well, we move the 1/2 down there, and we move the x squared down there, and it's rearranged. If we want to do it this way, we move the 2 up top, and we move the x squared down below. Both of these mean the same thing, because if I take 1 divided by 1 over 2, that just equals 2. The 1 overs cancel out, and the 2 moves to the top. So this is 1 over 2, which is the same thing as 2. Okay, and that's it. That's how you rearrange it. Okay, so this is a board question, so try this on your own and see if you can isolate t. So pause the video. So you'll see that this equation looks like this. These absolute symbols don't make a difference, and this just means it's a vector, but you can write it out like that. You don't have to leave those absolute symbols on. So t is going to move to the top. That's the first thing we have to do. And then we just move VC diagonally down below, and then it's rearranged. So just move things diagonally like that, and you'll never get one wrong. So these are the two most difficult situations. So rearranging with adding and subtracting. So this is the first situation. So addition and subtraction can be treated like a single unit that's being multiplied or divided as long as you move them together. So we have this equation here. Isolate t, d equals vf plus vi over 2 t. And you can see that t is by itself. So when t is by itself, it means that it's on top. So I'll write it out. I don't need to put those vector symbols in there to rearrange. I'm going to put t on top because it was by itself in that equation, and this is what it looks like. So we want to isolate t, so we can just move this 2 to the top like that. And then we can take VF and VI. I can't move VF down there by itself. That's not allowed. But if I take this whole thing in brackets and I move it down there, then it's allowed. And that's it. That's how you'd rearrange it. Okay, so as long as you move your adding and subtracting together, when it's in brackets like that, it's no different than the first way we did. Okay, situation 2 is a little bit trickier. So if moving the variables that are being added or subtracted together doesn't help you isolate the variable, you must subtract or add the variable from both sides to move it. So with this example here, we have, oops, let me switch my screens. VF squared equals VI squared plus 2AD. So these two things are being added together, and we want to isolate A. So the only way that I can move one of these down there is if I move the whole thing. So if I move VI squared plus 2AD down here, well, that doesn't help me isolate A because that puts A on the bottom, and that's never what we want. We don't want to find something when it's on the bottom. So my only other option is I got to get rid of this. So I can't move VI squared down there because I have to move them together. So I have to subtract a VI squared. And VI squared minus VI squared is 0, so it gets rid of it. But if I do it to the other side, then I have to do it to this side. So I end up with VF squared minus VI squared, I'll put those in brackets, is equal to 2AD. And now that I have it like this, well, I can move that 2 and the D down below, and I'm rearranged. That's it. Okay, so let's do a couple board questions. Okay, so I'll put both of these up, see if you can do it. Isolate VI in both situations, but they're different in each situation. Okay, so pause the video and see if you can do it. For the first one, we have D equals VF plus VI over 2. So we want to isolate this. Okay, we can move the 2 up top. That's not a problem. We can move the T down below. And now we just have adding and subtracting on this side. So the big mistake that people do is they'll try to put the VF down here. You can't do that. That's not allowed, right? The only way that we can move it down below is if we move it together, but that doesn't help us isolate VI. So what we need to do is we need to subtract a VF from both sides. Okay, I want to subtract a VF from this whole side, and I want to subtract a VF from this whole side. So what I'm going to end up with is 2D over T minus VF. And that equals VI. So this VF and this VF will cancel out. What a lot of people will do is they'll have this on the bottom, but what that's saying is that we're taking and we're subtracting a VF over T, and that's not what we're doing. We're not subtracting VF over T. So we're taking this whole thing and we're subtracting a VF from it. So this is what it has to look like in the end, or else it's wrong. The other board question, D equals VIT plus 1/2 AT squared. What I would recommend with this one is just keep that 1/2 on top. Keep it a variable that looks like that. So we're trying to solve for VI. So the first step that I have to do is I want to get rid of this 1/2 AT squared. I can't move it down below because it's being added. So what I have to do is I have to subtract a 1/2 AT squared. So that'll get rid of it from this side, but that means I have to subtract a 1/2 AT squared from that side. So I get D minus 1/2 AT squared is equal to VIT. Okay. And then my very last step, I'm moving it diagonally, but essentially what I'm doing is I'm dividing this side by T, so I need to divide this whole side by T. That'll cancel out. That's why I move it diagonal like that. And this is my final answer. So it needs to be, the whole thing needs to be divided by T. And don't worry about simplifying that because that's being added. You can't really simplify it, and it just would make it messy. Okay, so the last two situations that we see is, well, one of them is isolating a squared variable. So rearrange the formula as normal. When the squared term is isolated, square root both sides. So this is our example here. So let's do that example. So we're going to isolate R. So we have G equals GM all over R squared. And we want to isolate R. So our first step is just rearrange it as normal. So I'm going to get that R squared up top. And then I'll move the G down below. So I'll switch those two. And then to get rid of this squared, we have to square root it. But if I square root this side, I also have to square root this side. Those squared and square roots will cancel out. So I end up getting GM all over G, and it's all under square root. My next example is isolating a variable with a square root. So my first step is square everything. That'll get rid of our square root, and then rearrange as normal. Okay, so we're going to isolate L in this situation. So we have T equals 2 pi square root L over G. And I use a handwriting L just so it doesn't look like a 1. So whenever I have a square root, I'm trying to find something that's square rooted. I want to isolate this. I'm just going to square everything, and that gets rid of the square root, because square roots are messy and people don't like them, so let's get rid of them. So we have T squared, 2 squared is 4, pi squared is pi squared, and L squared square rooted is L, G squared square rooted is G. And because we just have multiplying and dividing, you can always extend that line if it's just multiplying and dividing. Okay. And now we want to isolate for L. Well, let's just rearrange. We'll move the G up top, and then the 4 pi squared down below. And I'm rearranged. And that's it. Okay, so let's do a couple board questions. Pause the video once you see the question, and see if you can do it. Okay, so these are my two board questions, isolate V and isolate K. So for the first one, we have AC equals V squared over R. So we want to isolate V. So I would just move the R up top. And then to get rid of the squared, I would square root both sides. So we end up with RAC equals V, and the RAC is square rooted. Okay, for the second one, I have T equals 2 pi square root M over K. And I want to isolate for K. So I'm going to square everything. And I end up with T squared equals 4 pi squared M over K. I can extend that line there. And I want to solve for K. So I'll move K up top. And then I move T squared down below. Okay, that's it. That's how you rearrange equations. So there's some homework with rearranging equations. So give these a go. A to G are all pretty good. They're all pretty reasonable. But standard of excellence is H. I won't give you something as hard as H. And I just want to make you aware of an error in the answer key. So there is an error in the answer key for one of these. So for, let me write on here, 1C, it gives the answer in the back as VI squared is equal to VF squared minus 2AD. So that's not fully isolated because you were trying to isolate for VI. So the last step that you would have to do is square root this side, and you would also have to square root that side. So the actual answer should be VI is equal to square root VF squared minus 2AD. And because there's adding and subtracting this square root and this square doesn't cancel out. This is the only correct final answer that you could give for 1C.